Hello everyone, welcome back again on the same series of videos on differential equations. So till now what we have done is we know about the order and degree of differential equations, and also we have an idea what do we mean by the solution of a differential equation. So for better understanding, let us do some examples. So this will make our life easy, or our understanding fairly well. So let us take an example. A differential equation be dy by dx plus d4y upon dx4 whole square plus d5y upon dx5 plus minus sine x to the whole power 1 by 4, okay, equal to 0. So as we know, the order of a differential equation is nothing but the coefficient of highest order derivative. So highest order derivative is this, and its order is 5. So order of this differential equation is 5. Now what we have to do for degree is, we know that in case of degree, we define the degree only for those differential equations in which are the function, or in which function in which either dependent variable means y, or any dn y upon dxn is not in the form of transcendental functions. This means there is no term involving, that is sine of y or cosine of dny by dxn for any n. So such functions are called sin x, exponential function, logarithmic functions. Such functions are called the transcendental functions. And what are the transcendental functions? We can describe, but it is not necessary. So we can say this dependent variable and any of its derivative must be in the form of only algebraic functions, okay. And also each term in the differential equation must be free from the fractional power. This means any dny by dxn. In this case, we can take n from 0 to any 0 and any natural number. So let us find the degree of this differential equation. As we know that this should be free from the fractional power, so what do? We bring this term to right hand side, so it will be easy for us to uh, free this equation from the this power 1 by 4, and we will take the fourth power of the both the sides. So if we do such, then we will get that d5y upon dx5 minus sine x is equal to dy by dx plus d4y upon dx4 to the whole power 4 to the whole power 4. So this will be into 4, okay. So the highest order derivative is this, and its power is now 1. So the order, a degree of this differential equation is 1 and order is 5. And clearly you can see that this is not a linear differential equation, so it is non-linear, okay. So the important thing that one should remember all the time, that the terms involving which type of term, that is sine of dny upon dxn, cosine or any trigonometric function, and exponential. that is e to the power dny upon dxn, or logarithmic function log dny upon dxn. And also we know that hyperbolic function, that is sine hyperbolic dny upon dxn. And here remember that we can take n 0, 1, 2, 3 up to any natural number. So if we put 0, so this term will be d0y upon dx0. This means that zeroth order derivative of y with respect to x. This means we have not taken any derivative. This means this is simple y. And if we put 1, so this will be d1y or dy by dx, and we can put any. So what we have to remember is that if these type of terms are included in that differential equation, then we will not able to define the degree of that differential equation. It is not that we are not able to tell, but we don't define, because what do we mean by transcendental functions? If we take the any derivative of this function, so after once it will go cosine, and after that one cycle it will be sine, and then it will be, but sine will be changed. After four cycles it will be same function, so we cannot define the degree. And the same way for exponential function and hyperbolic functions. So we define the degree only for the algebraic functions. This means, as we have discussed, you can check the previous video. Now hopefully the idea will be clear, and you will not feel any problem in defining the degree or determining degree, order, and the linearity of a differential equation. So let us take from here last time what we have done, that what do we mean by a solution of a differential equation. So any function of independent variables is called a solution if it satisfies the differential equation. So let y is equal to f of x. If it is a ordinary differential equation, then it will contain only one independent variable. In that case, any function of x is called a solution if it satisfies the differential equation. This means if we talk about this differential equation, then what we have to do, we put we find out the d5y upon dx5 and put it here, minus sin x, that is equal to dy by dx. We find out the dy by dx and put it here, and find d4y by dx4 and put it here. If it is satisfied, this means this side is equal to this, then we say that this is the solution of that differential equation. So in if as we have also discussed, if we have a nth order differential equation, then we have n number of arbitrary constants. So but we are not interested in such cases that we have to put an arbitrary constant in solution, but we want to solve a physical problem. As we have discussed thoroughly that differential equations are widely used in many areas, almost every area of science, technology, medicines, and including weather forecasting, and in any physical problem or any physical programming. So we are interested in solving our physical problems. If we are solving a physical problem, then we know about that problem. That just take for example, let an example of Newton's laws of motion. Let we have a ball, this is a ball, and this is our ground. Okay, hopefully it will be clear. and this be height h. Okay, and what do? We drop this ball from here. So in this ball, what will be the force? If the mass of the ball is small m, so there will be a downward force due to the gravity of the earth. Because we are on the earth, so it will feel force downwards due to gravitation of the earth. So let the acceleration due to gravity be g, then force mg will act downwards. Okay, if mg force acts downward, then from the Newton's law of motion we know that mass times acceleration, that is mx double dot is equal to mg. Okay, so from here x double dot is equal to g. We know that g is a constant and the acceleration due to gravity is constant. Now what we can find, we can tell about the velocity. What will be the velocity after this much of time elapsed? So let us find for the velocity. So we know that velocity is x dot. And what do we mean by x dot? This means first derivative of x with respect to time. This is a special things. A symbol means this symbol is denoted in this fashion. We denote the time derivative, and in this fashion we denote the derivative of one for any, just like we can denote dy by dx is x dot. Okay, so x double dot is g. So we have to find the velocity of this particle after a certain time. So x d upon dx of x dot, d upon dt of x dot will be equal to g. So and we know that this we can for convenience we can write this x dot is v, because we denote velocity by v. So dv by dt is equal to g, and from here we can write dv is equal to g dt. Okay, and we integrate this. Okay, so let want the velocity at a certain time t, and it started from some time t1, and we want it time t. So let when the time is t1, its velocity will be something. Let whatever it be, let it be v t1. Okay, or v of t1, and let this be v of t. So what will get, v of t minus v of t1 is equal to g of t minus t1. Okay, but as we know that we released the ball, this means when time was initial, we can take this time t1 is 0, and it is equal to 0. We have not given any velocity or additional velocity to this particle. So it t is equal to 0 or t1, what we have done, and we can take t1 as 0. Okay, okay, and if we don't take a t1, then this t will be some t1 plus something. So for the simplicity we take this t1 is 0. Okay, and v of t1 is equal to 0, so we put it here. V of t is equal to gt, because t1 is 0, and we obtain that v is equal to gt. Okay, so such problem in which we know these condition at one place, such problems are called the initial value problem. Okay, this is in initial value problem.